Hey, it's Mr. Lineski here with another edition of the Top 5 and Under 5 for Unit 4 Triangle Congruency, where I go over the top 5 things you need to know to help you prepare for your Unit 4 test. Let's get started. Number 1, we need to know that the angles of a triangle add up to equal 180 degrees, not the sides. So I have two triangles here, one with angles, one with sides. I want to talk to you about how you would go about solving those problems. So for the first one, notice we have all angles here. So this is something we go, oh, we have three angles, and these add up to 180 degrees. So we would simply add all three numbers and set it equal to 180. In this problem, do not confuse sides with angles. These sides do not add up to 180. You want to look for context clues to lead you to say, oh, this is isosceles, so set these two things equal together. Remember, these markings actually mean something, and that means that those are congruent. So we would set those two equal. Moving on to number 2, we need to know the classifications of the triangle. So each triangle has a classification by an angle and by a side name. For the angle names, we have obtuse, which means that it has one angle that is more than 90 degrees. We have acute, which means that all three angles are less than 90 degrees. Right, which means that it has one 90-degree angle in it. And equiangular means that all three angles are equal to the same number, particularly 60. And so the side names, we have scalene, which means that none of the sides are the same. Isosceles, which means that at least two of the sides are the same. And equilateral means that all three sides are the same. As a reminder, equilateral and equiangular are sort of married together. Those two names always go together. If I say something's equilateral, it has to be equiangular. If I say something's equiangular, it has to be equilateral. As a reminder, when it's equiangular, those three angles add up to 60 degrees, or equal 60 degrees, I should say. The triangle congruency, there are 5 ways to prove triangles congruent. These are the 5 ways. The first way is side, side, side. So as we're looking at these problems, we always want to look for those hidden figures, the things that we can mark additionally that weren't given to us. So in this particular problem, we can mark a shared side. And keep in mind, when you're trying to say, well, how are they congruent, it's best to try to ignore one triangle and look at what you have. We have a side, and a side. Over here, our hidden figure is a set of vertical angles. And so again, when I ignore one of these triangles, what do I have? I have a side, an angle, and a side. This one is our special case problem called hypotenuse leg. It is a version of angle side side, ASS, which we know does not exist because that's a bad word. But it does work if it's a right triangle. So we need to sort of have 3 things. We need to have a right angle, we need to have a leg, and then we have our shared side here, which acts as the hypotenuse. So this is hypotenuse leg. Over here we have angle side angle. So our hidden figure there is a shared side. Notice we have parallel lines marked here. Remember, the arrows mean parallel. Parallel does not mean congruent. So what we need to do here is mark our alternate interior angles. So we have a set here, and because we have 2 sets of parallel lines, we also have a set here. So this would be angle, side, angle. Over here, we only have 1 set of parallel lines, which means we need to trace over those parallel lines and trace over the transversal. And when we look at the green section, we have this and this, angle, angle, and then we have our shared side. So those are the 5 ways to prove triangles congruent. Remember, angle, 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 and angle, side, side, or side, side, angle do not exist. All right, moving on. We have the hidden figure helpers. In proofs, if you're working on proofs or looking to say why things are congruent, we want to always look for things like shared sides. So that's whenever 2 triangles are pushed together, and we call that reflexive property. That's when we say stuff like AB is congruent to AB. Vertical angles, it's when we sort of have that X figure sort of crossing each other, and those are vertical angles. So we call that vertical angle congruency theorem. Keep in mind we have CPCTC, which is what we use in a proof whenever, instead of proving triangles are congruent, we're trying to prove something else, like the angles are congruent or sides are congruent. And then if we see parallel line markings, typically that's going to lead to alternate interior angles or occasionally corresponding angles. So the example that we looked at of that, something like this. If these are parallel, these are my alternate interiors. And then finally we have number 5, which are the triangle properties for isosceles and equilateral triangles. So if I have the 2 legs in a triangle are congruent, so let's just say these 2 legs were congruent, then I would be able to say that the base angles are congruent. The base angles are the angles that are opposite those 2 sides. The converse of that is when the base angles of the triangle are congruent. So let's say that those two angles were congruent. I would be able to say that the sides opposite those are also congruent. And then finally, if all the angles of a triangle are equal or marked equal, like so, we would be able to say that all of the sides are also equal. Okay, those are your 5 things. Thank you for watching. I know it, and now you know it.